2 log k to 1 over 2 times k. See, because 1 over 2k is 1/2 times the p equals 1 series. And this is a theorem we do have to work with. If we have a scalar multiple times a divergent series, it's still divergent, and vice versa convergent, right? Scalar multiplication does not change the convergence or divergence of a series non-zero scalar multiplication. If I have multiplication by 0, I can change divergent to convergent, because if you multiply any series by 0, you get the 0 series. You've changed what it is. Otherwise, you're just rescaling, and that doesn't change the convergence or divergence. There's number 14. You guys have other questions, don't you? Sorry about my butchering of the alternating series test today. So sad. I did actually prepare for that, but I must have, I think I tricked myself when I was writing my notes. Although I didn't use my notes today. Maybe I can only blame myself today and not my earlier self. I don't know. Anyway.
Did you prove 12.2 number 12 in class?
12.2 number 12. I mean, I've mentioned that this is true. I don't think I proved it. But I think if you follow the It seems to me like parts B and C might help you prove. Well, in particular, part B. I think if you prove the identity in part B, then it should be a simple matter to prove well. Yeah, I think if you have the identity in B, you can prove the thing you're supposed to show there. Yeah. I mean, perhaps the wording of the question is a little bit confusing. What he wants you to understand is that the convergence or divergence of a series is really in no way tied to anything except for the tail of the series. So basically, if you have the sum k equals 0 to infinity of a sub k converges, if and only if what? The sum of k equals 2j to infinity of a sub k converges. This assumes that like a naught, a1, well behaved, okay? In other words, I don't have some stupid thing like, oh, well, the formula involves 1 over the natural log of k, so when you plug in 1, it doesn't make sense. That's not what we're thinking about here. All right, like this, for example, if I plug in 0, that formula is not cool, right? We're not thinking about that sort of thing right now. We're assuming that the a naught, a1, a2, a3, a4, a5, blah, 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 these are all well-defined things. Then that being settled, this converges, if and only if that converges. What's the relation between their nth partial sums? So the nth partial sum here is what? K equals 0 to n, right, of a sub k. let's call over here, let's call this S bar. Well, I'll tell you, I'll put a J up here. So what's the nth partial sum of the one that starts at J? Right? And of course, A sub k. How are these related? Yeah, A1. Right? In other words, this is A0 plus A1. So look at this identity. I mean, this is a stone cold formula. This is true in the convergent case, in the divergent case, whatever. And that ties the convergence and divergence of the one that starts at J and the one that starts at 0, and they are stuck together, right? If this converges, right, here you have a finite number, and this. Can this diverge? Absolutely not, because if this diverges, then that implies this diverges. So convergence of this implies convergence of that. Likewise, if this diverges, it forces that to diverge, because this is just a number. That's what he's trying to guide you through in parts A and B. Yeah. We used this idea just a second ago when I related the standard p equals 1/2 series to the shifted one. It's almost the same song and dance. You guys have another question? I probably have time for a hint, but not a solution. Although I don't know if you want to take my hints today. You guys get all the geometric series ones just fine? Those are the earlier problems, right? I like the geometric ones. You guys didn't ask me the easy ones. These comparison ones are the hard ones, right? Number 12 and 12.3?
Yeah, compare it to 1/k.
This I think if we use limit comparison, on number 12 we have k times k plus 1 times k plus 2. Now here's what jumps out at me when I look at this. This is intuition. So I mean, could we use a basic comparison test? Oh yeah, we could, couldn't we? Fine. I'm looking for a problem where limit comparison shines, but I think I'm just being silly, because here this is obviously less than or equal to what? 1/k times k times k. Oops. Sorry. I'm sorry. I don't know what that is. I've never heard of that group. If you could explain to me who they are. Sorry. Whatever. All right. What am I talking about? I don't know. All right. So that converges. So something larger than the given series converges. So yeah, by basic comparison, p equals 3. Convergence, yeah. You don't have to just ask about hard questions. It's okay to ask about easy questions. It's nothing to be ashamed of. I mean, I have things to be ashamed of. But oh well. All right, I'm going to push back the homework one more day.